Welcome everyone. In today's Decoding Dyscalculia session, I will be exploring how to teach decimal place value in ways that genuinely support learners with dyscalculia. The focus is on approaches that make decimals feel logical, manageable, and relevant to real life. I will be using concrete methods, tactile tools to show the actual size and value of decimal parts so learners build meaning before symbols. Visual supports, scaffolds that reveal structure and relationships, not just digits on a page. Consistent language, phrasing that reduces confusion and strengthens understanding of tenths, hundredths, and thousandths. Games-based practice, activities that provide repetition in low-pressure, engaging ways, helping learners rehearse skills without stress. Decimal understanding isn't just a maths skill, it's a life skill. We use decimals constantly, when comparing mobile phone tariffs to get the best deal, for example, or figuring out if we have enough storage for a game update, even checking if a swim time was faster than the previous week. When learners struggle with decimals, they often struggle with independence. Our goal as educators is to make decimals meaningful, not mysterious. When teaching decimals to learners with dyscalculia, we always begin with concrete experiences. We don't start with symbols, we start with a unit they can see and touch. A piece of air-dry clay or putty, a square cut from a maths book. This unit becomes our one whole. This slide, provided by Kat Edel and Rob Jennings from the Dyscalculia Network, show that how they use air-dry clay when teaching decimals. Here, a 1 has been split into tenths, hundredths, and thousandths. Pieces of air-dry putty can then be used alongside base 10 blocks to model calculations with decimal numbers as shown here. When teaching online, I use a square cut from a maths book. This unit becomes our one whole. Next, we show how cutting the whole creates smaller equal parts. Cutting one whole into 10 creates 10 equal pieces. Each piece is 1/10. Cutting each tenth into 10 equal pieces creates 100 equal pieces. Each piece is 1/100th. The pieces are tiny now, but if we could cut each hundredth into 10, we would create 1,000 equal pieces. Each piece is 1,000th. This approach isn't about memorizing facts, it's about feeling the size of these pieces, seeing how they shrink and how they relate to the whole. Once learners have physically handled wholes, tenths, hundredths, and thousandths, we show how these ideas map onto a place value chart. This step helps them connect the tactile experience to the written structure of decimals. A key message to emphasize is that we stop cutting paper into tiny pieces, not because the idea changes, but because the pieces become too small to work with. At this point, we switch to tokens, counters, discs, or even drawn dots to stand in for the pieces. Why not invite students to draw a place value chart from memory? This is a powerful assessment tool. Watch closely as they set it up. Do they include all the columns they need? Do the columns run in the correct order? Do they confuse tenths with hundredths? Their drawing reveals what they truly understand, not what they can copy. Offer gentle, specific corrections reinforcing the structure. The goal is to help students internalize the layout so it becomes a reliable anchor for future work. Now we're ready for visual methods, zooming in on a number line. We begin with a number line from 0 to 10. These are whole numbers. Explain to students that we're going to take a magnifying glass and zoom in on just one part of the number line, between 0 and 1. Decimals live between whole numbers. When we zoom in, we can see tenths. A decimal with a 1 in the tenths place represents 1/10. Then we count 1/10, 2/10, 3/10, and so on. 10/10 equals one whole. Students often get stuck when they see a 9 in a place value column, and mistakes are common. If this happens, practice counting on a place value chart. Remind the students that there is no digit for 10 in a single place value column. The highest digit is 9. Anything beyond that must be regrouped and exchanged for 1 in the column to the left. In this case, 10/10ths regroup into one whole. Now let's zoom in even closer. Between the tenths, we find the hundredths. A decimal with a 1 in the hundredths place represents 1/100th. Then we count 100th, 200ths, 300ths, and so on. 10/100ths regroup into 1/10th. Students need a clear way to see that decimals, fractions, and percentages are connected representations of the same quantity. Models make this connection visible. In this example, I've shown a student 2/10ths in multiple forms. 2/10ths can be represented as 2 shaded parts out of 10 on a fraction bar or fraction grid. I label it as 2/10ths and 0.2. I place it on a number line. Now I show the student 20/100ths. I shade 20 parts out of 100 on a 100 grid. I label it as 20/100ths, 0.20 and 20%. I emphasize that although the picture looks different, the value is the same as 2/10ths. I return to the number line and show that 0.2 and 0.20 land in the same place. This reinforces that the representation changes, not the quantity. Only once learners are secure with concrete and visual models of decimal place value do we bring in abstract problem solving. This sequencing matters because concrete and visual experiences give students a sense of scale, structure, and relationships. When they finally meet the abstract notation, it feels like a translation of what they already understand, not a brand new layer of confusion. This reduces cognitive load and supports long-term retention. Even when solving abstract problems, some students will still need to create their own supports, place value charts, color coding, or number line sketches. These are not shortcuts or crutches. When they come after deep conceptual work, they are tools for reducing working memory strain, anchors that help students organize information, signs of independence, not dependence. Encouraging students to design their own aids strengthens ownership and confidence. Whatever method we use, consistency in language is essential for learners with dyscalculia. Using phrases like 5/10ths or 5/100ths keeps the fractional meaning of decimals alive in the classroom. It reinforces the idea that decimals are built from parts of a whole, not from mysterious symbols. Whereas allowing students to name 0.51 as 0.51 causes common misconceptions to form. Shortcuts such as move or drop the decimal point or add a zero can feel efficient, but they are fragile strategies. Without deep conceptual understanding, they often lead to errors, especially when learners encounter unfamiliar numbers or operations. These common shortcuts should be avoided. Games and structured activities make rehearsal feel safe, predictable, and low pressure for learners with dyscalculia. They shift the focus from getting it right to exploring patterns, which lowers anxiety and increases willingness to try. Matching games help learners connect decimals, fractions, and percentages without the pressure of formal questions. Decimal bingo turns repetition into a playful routine, giving students multiple exposures to the same structures. Place value sliders allow learners to manipulate digits physically, reinforcing how value changes across columns. Grid shading challenges strengthen understanding of tenths and hundredths through visual, countable models. These activities make repetition feel purposeful and enjoyable rather than stressful, helping learners build fluency through gentle, consistent practice. To close, remember that learners with dyscalculia can understand decimals when we teach in ways that align with how their brains process information. The sequence matters: concrete first, visuals next, abstraction last, supported all the way through by steady language and predictable routines. These approaches honour the learner, reduce cognitive load, and make decimal work feel logical rather than intimidating. Thank you for taking the time to watch this video today. I hope you found it useful.